Okay, our perfect predictions, don't look so great. Let's see how they do if we split the data. Okay, what kind of a score will we get? Okay, so how do we do that? Well, what's nice is sklearn has built-in methods for this, and so we can do from sklearn dot model selection, okay, import, and it's train test split. This does exactly what it says. It splits the data into a training and a test set. Now, when you do that split, okay, it's sort of interesting because you've got an X and a Y, but if you're splitting it, now you need a training and a test set for both X and Y. So in effect, you end up with like a 4 tuple. And so it's going to be X train, comma, X test, Y train, comma, Y test equals train test split on X and Y. Okay, that is the key. So we're splitting our data into a training and a test set. And this order is the order that you need. It's X and then Y, train and then test. Okay, let's go ahead and run that code. Now what? Well, now we're going to sort of reset the model build process, right? So we're going to reinitialize model, and we'll do model equals, it's still just a decision tree classifier, okay? Great. And now you want to think about fitting the data, model.fit. What are we fitting it on? Okay. Well, you've got to think about this carefully. Let's see if you can get it right. Before we fit it on X and Y, right? But now we have split our data into a training and a test set. So when we're fitting the model, what do you think it should be? We had X and Y. So that's right, we want an X and a Y. Well, when we're fitting the data, that's sort of when you're also training the model. And so it should be X train, Y train. Okay. Next, we want to score the model. And this is the whole point. We do not score the model on what we train it on X train and Y train. We use instead, right, this is the same. We want it different. This is the whole point of the X test and the Y test. Now, what are the difference in these data sets? Train test split by default uses like an 80-20 split. You can modify those numbers. And so basically 80% of the data is going to train on and test on the 20%. So the model here, it is reducing the data sum to 80% of it. It's going to build a model that the best that it can on that. We're expecting a very strong model, right? It's a decision tree. Decision trees are powerful, as you see. But now we're going to test it. Okay, we're going to test it on the test set, right, by scoring it. And so now when we get the score, it's going to be scoring data points it's never seen before. So it's going to be taking, 20% of the data. There's like 300 plus rows. So that's like roughly 60 rows of new data and fitting it in and see how many of the predictions it gets right. So this is where the generalizing to new data is key and now will be our reality. And let's see what we get by comparison. So let's run this code and we get a respectable 75%, but nothing near the 1.0, right? That is the point. So this may have been a great model, but this is more like a realistic score. This is what it's predicting on data that it has not seen before. Okay. And so let's just copy this and do it again. And what we're going to do next is we're going to make some changes. Okay. And we're going to look at just some small changes that we can make to see if we can get a better score.